Hello students, in this class we discuss about the most important question that is valence bond theory. By using that valence bond theory, you have to explain the formation of the four complexes. Out of the four complexes, in your board exam, definitely one formation will ask for 3 marks. First question is formation of CONH3 3 plus by using valence bond theory VBT. In the exam they can ask by using valence bond theory explain the formation of CONH3 3 plus and explain the magnetic property of the complex. For this one, first you consider the central metal atom. Central metal atom is cobalt. CO means the cobalt. Atomic number of the cobalt is the 27. Electronic configuration of the cobalt is argon, (3d7), 4s2, 4p0, 4d0. This is the outermost configuration. Oxidation state of cobalt. Oxidation state of cobalt in this complex is 3 plus. Because NH3 is a neutral ligand, its charge is 0. Configuration is a 3 plus. Oxidation state of cobalt is a 3 plus. Cobalt 3 plus configuration is argon 3d6, 4s0, 4p0, 4d0. You consider the box diagram, that is cobalt 3 plus configuration. Cobalt 3 plus configuration is 3d. D subshell contains 5 d orbitals. This is 3d. D6 means 6 electrons. According to Ohm's rule, you have to write the configuration as 4 unpaired electrons. This is a 3d6. 4s, s orbital. S subshell has only one orbital, s orbital, 4s. Then you consider 4p also. P subshell has 3p orbitals. These are vacant, 4p. Here no need of writing 4d. Then this complex contains NH3. NH3 ligand. That NH3 is a strong field ligand. Then in the next point, in the presence of strong field NH3 ligand, you observe the cobalt configuration becomes cobalt configuration. This is the 3d subshell. These electrons get paired. Again, it's the Ohm's rule. These 4 unpaired electrons, they get paired. Again, it's the Ohm's rule, forming 2 vacant d orbitals. This is 3d. This one has 4s, already vacant, and 4p. 4p already vacant. Out of these vacant d orbitals, 2 d orbitals, 2 3d orbitals, 2 3d, 1s, and 3p orbitals. They undergo hybridization. The hybridization name is D2sp3 hybridization. D2sp3 hybridization. They undergo D2sp3 hybridization to form 6 d2sp3 hybrid orbitals. Then you consider this is the 3D. 3D has 6 electrons, they get paired. 3D. You write separately as the hybrid orbitals, because according to hybridization, we know that hybrid orbitals having same energy. 6 d2sp3 hybrid orbitals. These are the d2sp3 hybrid orbitals. All d2sp3 hybrid orbitals, they are having same energy. Vacant d2sp3 hybrid orbitals. Such vacant d2sp3 hybrid orbitals, they overlap with filled orbitals of the ammonia. That each ammonia donates 2 electrons. Hence, 12 electrons. 6 NH3 donates the 12 electrons. 12 electrons, they are from the 6 NH3 ligand. They get filled in the hybrid orbitals. Directly write in this step only. This is the hybrid orbitals. d2sp3 hybrid orbitals contain 12 electrons from 6 NH3 ligand. Then entire this configuration, now it is taken as CONH3 6 cobalt complex. CONH3 6 3+. Up to this stage, metal ion only, cobalt. This is complex. Then you observe this formed complex. Formed complex contains paired electron. There is no unpaired electron. All are the paired electron. Paired electrons are present, hence it is diamagnetic. Complex contains paired electron. Due to presence of paired electron, it is diamagnetic in nature. They can ask the magnetic nature. At that time, you consider it is diamagnetic due to paired electron. Due to paired electron. Due to paired electron, it is a diamagnetic. Then, the hybridization is d2sp3 hybridization. According to d2sp3 hybridization, that is inner d orbital is involved. Then the geometry of the complex. Geometry of the complex is inner octahedral. Inner octahedral geometry. Inner octahedral. Due to inner d orbital involved, 3d orbital is involved. Hence, it is an inner octahedral. This is about the magnetic nature and geometry. Inner octahedral. If you know, still you can write this is diamagnetic due to presence of unpaired electron. This can also considered as low spin complex. Low spin complex. If you know, then only you can write it that one as low spin complex. Low spin complex or spin paired complex or spin paired complex. Spin paired complex. Just you stop up to diamagnetic only. If you know, then only write low spin complex or spin paired complex. In annual exam, they ask what is the hybridization of the complex, magnetic nature of the complex and geometry, and explain its formation. Just this term is enough for the 3 marks. This is about the formation of CONH3 6 3+ by using valence bond theory. For that one, you have to consider the cobalt ground state configuration, its oxidation state 3+ and its configuration represented in the box diagram. Then in the presence of the strong field NH3 ligand, electron pairing takes place against the Wundt's rule, forming 2d orbital as the vacant. That vacant d orbitals undergo d2sp3 hybridization. Then that the vacant d hybrid orbitals, they overlap with filled orbitals of the ligand. Totally, each ammonia ligand donates 2 electrons, one pair. From 6 NH3, 12 electrons. That 12 electrons, they get accommodated. They filled into the vacant hybrid orbital. Then this is considered as a complex, CONH3 6 3+ complex. The complex contains paired electron. Due to the presence of paired electron, it is a diamagnetic or low spin complex, or it is called spin paired complex. Geometry of the complex is inner octahedral because inner d orbital is involved. This is inner d orbital. 3d is the inner. If it involves 4d, then it is an outer. Inner d orbital is involved, hence it is an inner octahedral. This is about the formation of cobalt CO NH3 3 plus. Next we consider COF6 3 minus complex. Second one is formation of COF6 3 minus by using valence bond theory. Similarly, we consider cobalt configuration. Central metal atom is cobalt. Cobalt configuration. Cobalt atomic number is 27. Configuration is argon. Then 3d7, 4s2, 4p0, 4d0. Then in this complex, cobalt oxidation state is 3 plus. Cobalt 3 plus. Here it is x minus 6 equal to minus 3. X minus 6 equal to minus 3. Then x value is plus 3. Then cobalt 3 plus configuration is argon 3d6, 4s0, 4p0, 4d0. Then you consider the box diagram. Cobalt 3 plus configuration in the box diagram. In that box diagram, d subshell has 5 d orbitals. 5 d orbitals. This is 3d. 3d6. 3d6 means one electron has paired according to the Wundt's rule. This is 3d. 4s. 4s0. 4s vacant. One s subshell has one s orbital. It is vacant. 4s. 4p. P subshell has 3 vacant d orbital. 3 orbitals. All are the vacant. 4p. Then again you consider 4d. D subshell has 5 d orbitals. This is 4d0. This is the ground state configuration of the cobalt. This is the configuration of the cobalt 3 plus. Here, a fluoride ion is a weak field ligand. It is a weak field ligand. It is a weak field ligand that can be explained by using spectrochemical series. It is a weak field ligand. Hence, electron pairing takes place against the Wundt's rule. Electron pairing not takes place against the Wundt's rule. Hence, outer orbitals involved in hybridization. That outer orbitals are 1s, 3p and 2d. These are the outer orbitals. That outer orbitals involved in the hybridization. That hybridization name here is sp3. 1s orbital, 3p orbital, 2d orbital. Hence it is sp3d2 hybridization. The hybridization name of COF6 3 minus is sp3d2 hybridization. Then consider the hybrid orbitals. This is the d orbital, 3d subshell remains the same. This is 3d, 6 electrons. Then hybrid orbitals all are having same energy. We write 6 hybrid orbitals in the same energy level. These are the vacant. This is sp3 d2 hybrid orbitals. sp3 d2 hybrid orbitals. Then 4d, they are not involved in hybridization. Vacant. These are the 4d. These are the hybrid orbitals. Then these vacant hybrid orbitals, sp3d2 hybrid orbitals, they overlap with filled orbitals of the fluoride ligand. Each fluoride ligand donates the one pair, means 2 electrons. Totally 12 electrons. 6 fluoride ligands donate the 12 electrons. Those 12 electrons, they are from the 6 fluoride ligand. those 12 electrons they get filled in the vacant hybrid orbitals. You fill the vacant 12 electrons in these vacant hybrid orbitals. 12 electrons. These are the 12 electrons. They are from the 6 fluoride ligand. Then this is considered as the complex, that is COF6 3 minus. COF6 3 minus. You observe the formed complex due to presence of unpaired electron. This 3D contains unpaired electron. Due to presence of unpaired electron, the complex is paramagnetic. The complex is paramagnetic in nature. Paramagnetic. It is also, if you know, also you can consider it as high spin complex, or you can consider it as the spin free complex. If you know, you write these two terms. Otherwise, just you write due to presence of unpaired electrons, the complex is paramagnetic. It is enough. If you know, you write high spin complex or spin free complex. Then this complex involves outer d orbitals, outer s orbital, outer p orbital and outer d orbital, 4s, 4p and 4d. Outer orbitals involved in the hybridization. Hence the geometry of the complex is outer octahedral. This is about the formation of the COF6 3 minus by using valence bond theory. Right? As it is, you get 3 marks. First one is ground state configuration of the cobalt. 3d7, 4s2, 4p0, 4d0. Oxidation state is 3 plus. Cobalt 3 plus configuration is argon 3d6, 4s0, 4p0, 4d0. Then you represent that configuration in the box diagram. Then in the presence of weak field ligand, they undergo sp3d2 hybridization. Then forming 6 vacant hybrid orbitals. Those vacant hybrid orbitals overlap with filled orbitals of the fluoride ligand. They donate 12 electrons. Those 12 electrons get accommodated in the vacant hybrid orbitals. Then this is the complex COF6 3 minus configuration. That complex contains unpaired electron, hence it is a paramagnetic, also called high spin complex or spin free complex. Geometry of the complex is outer octahedral. In your annual exam, they can ask what is the hybridization, what is the magnetic nature and geometry of the complex, and explain the formation by using valence bond theory. You just write as it is. You can get the complete marks. In the next class, you can study the formation of other two complexes.